Hi, in this tutorial, I'm going to talk about inheritance. Inheritance is an important part of the Java language because it allows us to take classes that are related to each other and kind of build from them, starting with the most general class to classes that are perhaps more specific. So the example I'm going to do today is going to start with a class called person. So a person is just it just has two general things about them. They have a name and an age. And I've already written the whole person class from before with a couple different constructors and all the getter and the setter methods that go with both name and age. And then I've also written a method called greeting and then a toString method for a person. So today we're going to write the class. We're going to start with the class student. And student is definitely a person, but it's this more specific kind of person. And this is the idea of inheritance. So student would be the child class of person. Person is a little bit more general. Student's going to be a little bit more specific. So there are a couple rules that go into writing a class when you're doing inheritance. So a child class from a parent. And the first of these rules is when I go to do the class header here, when I say public class student, I need to include extends person. And that tells the computer that this class is kind of an extension of the other class, that a student is a special type of person. So what that's going to mean is the student's going to have all the attributes that a person has, name and age, and it might have some additional attributes. So we're going to give our student the attribute, we're going to say private int student number. So each student is going to also be given, besides a name and an age, they're going to have a student number. So when I go to write the constructor for a student class, we need to both give student number a value, but we also need to be able to give the name and the age a value. And the problem with that is if I look at the person class, name and age are private, so I can't directly give them values, and I don't want to declare new ones. So once name and age have already been created, we do not create them again. So you just need to work with the person class. So when I go to write the constructor, let's say I say public student, and let's say this is going to take in a name, an age, and a student number. Oh, I got a little typo there. Now, here comes the second rule of writing a child class. So the first rule, once again, was to use the keyword extends so the computer knows that it's a child class. The second rule is this. When I'm writing the constructor in a child class, the first statement in that constructor is a keyword called super. And super is basically there to then call upon the parent's constructor. So I'm going to say super name, comma, age. And then I'm going to give student number a value. So this dot student number equals student number. And I purposely use student number here because I wanted to bring back that keyword this that we learned a while back. And the keyword this is just indicating that this student number here is the instance variable, and this one here is just the parameter. So it's kind of just designating between which is which. You could, instead of having to deal with this, I could have given this a different name. I could have just called this int s, and then I could have just had that equal to s if you wanted to kind of simplify it a little bit. So those are really the only two main kind of what I would call rules of writing a class when we're doing inheritance. We must use extends and we need to use super. And what the super is doing right here is it's taking the name from this parameter and the age from this parameter, and it's sending it to the person's constructor. So if we go to person and we look at the constructor down here that wants a name and an age, it is actually sending those values in. Now, another kind of side rule about writing a child class is that any method that was written in the parent class that we don't intend to do anything different with, we do not rewrite. So I would need, for example, a setter and a getter. So public void set student number. And we'll just say int s. So then I'm going to say student number is equal to s, and I might have a public int get student number, and that's going to just return the student number. So these setter and getter methods for the student number are included here, but notice that I don't have a getter and setter method for neither name nor age, and I don't want one. I don't need them because they've already been done in this class, and any method that's in this class can be used by the objects of this type, and that's the whole idea behind this inheritance. Another kind of side note of inheritance is that I can have more than one class as a child. So just like your parents might have more than one child, so can class person. So I also created another class called programmer. So public class programmer extends person. And let's say a programmer has private string favorite language. So fav language. And so when I write the constructor for the programmer, so I would say public programmer, and let's say I'm going to take in a string name, an int age, and a string FL for favorite language. Inside of the constructor, so going back to that rule again, I need that call word super, and I'm going to send it the N and the A to the parent class, to the constructor in the parent class, and then I'm going to say that fav language equals FL. So really important that you're not redeclaring instance variables that were created in the parent class. And then we also talked about the extends and the super. And the programmer also needs to do the getters and setters for its instance variable, but none others. So that's kind of the idea of how a parent and child classes work together, some of the basics. One last thing I want to cover before we go is that when I go to create an object of these classes, so if I go into my main, for example, I've already done a bunch with person, but let's say I want to do some other objects of the other classes. So I can say student first equals new student, and I'm going to give that student a name, Pete, comma, the student's 15, and the student number is 3, 4, 5, 6, 7, 8. And I could also say programmer, sec equals new programmer, and again name Kim, say 25, and her favorite language is Java. So when I create my objects, I still use the same rule. Like when I go and I look at the student constructor, I still want to make sure that I match that. But notice that name and age aren't getting set here. They're going to be getting set in the person class. So then later, if I were to say system.out.println first.getAge, and I run this, And for right now, I'm going to go ahead and take all these other ones out, so it's the only one that you're going to see. And hopefully I don't have an error, which it looks like I might. Never mind, I think I just kind of pulled the trigger too soon there. So if I run it, you can see that it's printing out the age of my programmer or of my student, which is 15. But notice that in the student class itself, there is no get age, right? It was able to use the parents' get age in order for that to work. So that's kind of the neat part of inheritance. I'll be back in another tutorial with a little bit more on inheritance later.